Here are a couple of more problems on the Hinges handout. I'm going to do 9 and then I'll do 14. So with 9, let's take a look at this. It's 3a to the 5th power, b to the 2nd power. And that's all over, or being divided by 9 times a to the 2nd power, b to the 5th power. So the easiest way to think of this is to factor it out first, and then we'll try doing some of the shortcuts. So let's factor the top part first. So there's a 3, and we can't really factor 3. 3 is a prime number, so that's about as low as it goes in terms of factoring. A to the 5th power, we can do a times a times a times a times a 5 times, and then b to the 2nd power, b times b. Now let's factor the denominator. So 9 actually can be factored into 3 times 3. So I'm going to do that right here, 3 times 3. And then we've got a to the 2nd power, so that's a times a, and b to the 5th power, so that's b times b times b times b times b. So b 5 times. All right, now what we're going to do is see where we can find giant ones. Here's run right away. 3 over 3 is equal to 1, so there's one giant one. A over A is equal to 1. A over A is equal to 1. And then over here with the B's, B over B is equal to 1. B over B is equal to 1. So what do we have left? On the top, we've got 1, 2, 3 A's multiplying themselves. So A to the 3rd power. And then below, we've got 1, 3, and then we've got 1, 2, 3 B's. So b to the 3rd power. So that's what we got by factoring. So let's take a look at how could we have worked this by shortcuts. Well, first of all, you want to take the coefficients by themselves. So 3 over 9. If you look at 3 over 9 and you simplify that, you can divide the top and the bottom by 3. So 3 into 3 goes 1 time. 3 into 9 goes 3 times. So you'd have 1/3 out of 3/9. The next thing that we would look at is the first variable, or base A. And on the top, it's got a to the 5th power. On the bottom, it's a to the 2nd power. So normally, excuse me, what we would do is take the top exponent minus the bottom exponent, and we would get a to the 3rd. So that would be up on the top, because a to the 3rd. All right. Then when we look at these, b to the 2nd and b to the 5th. So if we take the top exponent and subtract 5 from it, we'll get a -3. And we know that a negative exponent means that it's dividing. And so it ends up on the bottom with a positive exponent. So if we take a look at this, we know that we don't need the 1 in front of the a, because 1 times a to the 3rd is just a to the 3rd. So we can simplify that to a to the 3rd, 3b to the 3rd. Okay. Another way of thinking of these in a shortcut is you just look at the exponents and you say, okay, which one has more, is greater? So this is a to the 5th, and this is a to the 2nd. So if we subtract one from the other, we know we're going to have 3 left up here. With the b's, if we subtract 2 from 5, we know we're going to have 3 left in the denominator. So that's another way of thinking of it too. Okay, so now we're comparing our answers using the shortcut to the factored version, and we see that we have the same answer.